Okay, well, today what we're going to talk about, y'all, is we're going to talk about congruence and transformations, section 4.1. We're going to draw and identify and describe transformations in a coordinate plane and use properties of rigid motions to determine whether figures are congruent and to prove figures are congruent. Okay, so what we're going to do is we've already talked a lot about the different types of transformations, but I just want to kind of go through and reiterate what those are real quick. Okay, so we had three different types of transformations that you guys have remembered, and then we had our fourth one that we talked about before. We had the translation, we had the reflection, rotation, and then we had dilation. When any of these three are performed, the shape doesn't change at all. It just moves. But this one, the shape changes, unless I multiply it by a scale factor of 1. So, for example, translations, those things just slide, right? Left or right or up and down. Reflections flip, okay? So they don't do much, they don't change at all. Rotation, these things just rotate around a point, okay? So therefore, these all are called rigid transformations because they don't change. And if the shapes don't change, that means that they're congruent. So rigid transformation means congruent. And another term for that is called isometry. So these three terms are used interchangeably with these three different types of transformations. Dilation always grows or shrinks unless you multiply it by a scale factor of 1. We usually won't ever do that, okay? But if it's multiplied by the same scale factor of 1, then it's just the same shape. Okay, so we're going to apply the transformation M to the polygon, which with the given vertices, and identify and describe the transformation. So what this is telling me is that I need to subtract x 4 from each one of my x values. This one's telling me I need to add 1 to every one of my y values. If you look, P is right here and P prime is right here. We talked about how P prime and P are related. P is called the pre-image and P prime is called the image. So it's the pre-image before it moves, and then it's the image after it moves. And if you look at this, it's sliding, correct? So it's sliding, it's changing directions, and so what it's doing is it's sliding over to the left 4 units, and it's moving up 1 unit. And so that is a transformation of translation. So since this is a translation here, what do we know about it? Well, we know that this is a rigid transformation, or in other words, an isometry. So those are our terms that we need to get familiar with. Okay, so the same type of idea here. This is the rule that's being applied. X doesn't change, but Y becomes a negative. So if you look over here at the graph, A is the pre-image, A prime is the image. If you look, the only thing that's changed is 2 became negative 2. Okay? Now, if this was already negative 2, then it would have just become 2. And you can notice what's happening here. It's a reflection across the x-axis, right? Now, since it's a reflection across the x-axis, it's also a rigid transformation and also a subject of isometry. So that means that the shapes have not changed their shape, they stayed congruent. Finally, our last example of this is pretty simple. If you look again, E here is the pre-image and E prime is the image. So after it's moved. If you look here, what has happened is the rule is saying that the x is going to switch places with the y and then become opposite. So for example, if I look at E and I pull that out, I have -3, 3. What this is saying is that my x is going to change positions with my y. So I'm going to put my y in the same position as my x and my x in the same position as my y. And then I'm going to change the sign on x. So now it becomes 3, 3. And there it is, 3, 3. This rule is the rotation. And if you notice, it's rotating 90 degrees clockwise around 0, 0, around that point 0, 0, which we talked about before. So around 90 degrees clockwise. That is also a rigid transformation because the shape has not changed. It's preserved its lengths. Okay, so just remember that it's a rigid transformation and it's an isometry. Now last but not least, here's a dilation. And as you notice, the scale factor is 3. And so that makes this become larger. So everybody always wants to say, well, Mr. Hostetler, this shape is moving. It's sliding. No, it's not. It's just growing. It's growing around the point 0, 0, not around the center of this little triangle. We talked about that earlier this year, but I just want to reiterate that this is not sliding. In fact, it's just growing. And since it's growing, this is not congruent, right? It's changed its shape. It's not a rigid transformation, and it's not isometry. Okay, so looking at this example, we're going to take a look at this real quick. This is telling us the rule to the polygon with these vertices. We want to name the new coordinates, okay, of the image points. So we'll call them D prime, E prime, and F prime. So D prime, it's telling us that we're going to take the x value and multiply it by 3, and the y value by 3. So if I take 1 times 3, I get 3. If I take 3 times 3, I get 9. Again, here, 1 times 3 is 3. Negative 2 times 3 is negative 6. And finally, 3 times 3 is 9, and 0 times 3 is 0. If you were to graph these, which I encourage you to if you don't know what the rule is, but if you know, we're multiplying, so that it has to be a dilation. It's actually growing. But the thing is you should graph these if you get confused as to what transformation you think it might be. You might just want to graph it so you can look at it and kind of see what's going on. Okay, so these are all the rules of the transformations. You have translation, which we've talked about, is where you add, right, A and B. Reflections, there are across the y and across the x. This is the rule of how you're going to change your coordinates so that you can get from your pre-image to your image. Okay. Rotations, there are 3 different types that we care about. We care about the 90-degree clockwise, the 90-degree counterclockwise, and the 180 degree. And you notice they're all going around the point 0, 0. So just notice what's happening with these as you look at the rule. And finally, the dilation, which again is not a rigid transformation if this k is equal to 1. But we're never going to really see that, so it's not going to be a rigid transformation because it's going to grow or shrink. And again, scale factor k. So I would copy this down or print it or something and maybe put it in your notes so you have it, because I want you to make sure you understand this. And if you have a question on this, we can talk about it. But the quizzes and stuff that we do, you know, you can use these on there. So just be aware of that. Okay, so we're going to determine now whether or not these are congruent or are an isometry or rigid transformation. So to do that, to be able to prove this, because we can't just go, oh yeah, they look the same. That doesn't work, obviously. We don't ever do that because in geometry we have to have some type of proof, okay, to be able to back our butts up, okay? So we want to make sure that when we look at this, that we're noticing what's happening. You should see that it's sliding, okay? But we have to be able to explain that, okay? So it's translating, right? It's actually translating how? Well, it's translating, the pre-image is this stuff, the image is this. So it's moving, if we just take point C correlates with point R, it's moving down 1, 2, 3 units, and moving to the left 1. So down 3, left 1. Now since I'm able to prove that it's translating, I can now say yes, these are congruent. And it's because they follow a rigid transformation, okay? One that does not change the shape of the shapes that are involved. So this one, when we're looking at this, we cannot just say, well, it's shrinking or growing, so therefore they're not rigid. No, we have to explain through one of the transformations, and we have to have a scale factor. So if you know it's dilating, which it is, then you have to come up with the scale factor. You can't just go, oh, it's dilating. Well, yeah, I know it is, but be a little bit more specific with it. Okay? So what we have to do is we have to look at what we have, which is the pre-image and the image. When you're looking at dilation, in order to figure out whether or not something is growing or shrinking, we can graph them, and now we notice that it's growing. And since it's growing, I know it's dilating from here to here. So what I always will do to figure out K, okay, to figure out what the scale factor is, I'm going to take whatever the number is in the image, and I'm going to divide that by the pre-image. And so I can use the coordinates. So for me, let's just look at P. P has a coordinate of x of 3, and A correlates with that, which is 2. So I take 3 divided by 2, which is 1.5. If you do that all down through here, you'll notice that each of these is 1.5. So that means that K is equal to 1.5. So in other words, this is a dilation where K equals 1.5. So no, these are not congruent, okay? So not congruent. And the reason why they're not congruent is because it's a dilation, which is not one of our rigid transformations. Okay, well that's it. So this is pretty simple. We've already kind of talked about it before, but just remember the 4 transformations. You got translation, rotation, reflection, and dilation. The 3 before that, so the translation, the rotation, the reflection, those are rigid transformations. They don't change the shape of the figure. Dilation will change the shape of the figure unless K is equal to 1, but we're not going to ever see that. So dilation is either going to shrink or grow. Okay, you have to understand that when you graph these, you're graphing the pre-image before it moves and then the image after it moves, and you need to be able to identify the moving so that you can actually prove whether or not something's congruent and not congruent. We can move things multiple times, which I'm going to show you in notes, okay, later, that we can take something and we can translate it, and then we can rotate it, and then we can reflect it. And we have to notice that string of events. But if it dilates at any point in time, then it changes the overall shape, and therefore it wouldn't be a rigid transformation. So our terms, rigid transformation and isometry, they mean the same thing, which means that the shapes are going to stay congruent whenever they move through the process of the transformation. So, all right, well, take it easy. Have a great evening.